I'm going to start a little bit with the methodology in terms of how the building came about. The first factor is the very fast schedule. It was funded by KIP funding. So we had a two-year program, which is really fast. So that really affected a lot of the decision process. The other factor is the integrated design process. Now again, everyone's very familiar with that, I think. So I'm not going to dive into a lot of detail, but that really was a key factor in terms of the whole team working together and coming through. Every element within the building had to function in different ways. And this diagram showing that sort of cyclical process of ideas that are being thrown out, being sort of bashed around, trying to refine those, costing them, developing them further. It makes a very exciting design team meeting. It's not the usual, everyone sits down and does their bit. Everyone is contributing. Quite long meetings as well. The third part of it is the charrette process. Now, I mentioned the fast schedule. There wasn't a lot of preparation prior to us coming on board in terms of developing this building and the program. So it was a question of bringing a lot of people on board very quickly. So we had a 3-day charrette where we go through the site on the first day, going through the site issues. Keep pointing to the screen. Then the next day, looking at the building itself, trying to get feedback from everyone in the room. And then on the third day, doing a very rapid sort of summing up and sort of feeding back to the group and what we've sort of learned from the group. Now, I say the group, this is students, faculty, staff, local officials, MPs, etc. So they're quite a large group, maybe 100% people. And if you're embarking on a living building challenge, you really need the buy-in from such a large group. And for me personally, I think what was most significant for a building that was so radically sustainable, in maybe 100 people, we probably had 1 or 2 naysayers in that whole group. There was a huge buy-in and a huge excitement for this project, and I think that's really a key to success. It can't just be coming from the architect or the design team or from the builder. It really has to have the support of everyone, including local officials, etc. So that's a little bit of the process. I'm just going to do a quick summary of the building just to orientate you, and then start getting into some of the design principles. So the image on the right here that you see was actually generated in the charrette, and I think it's credit to that process that it's actually still very true to the finished design. On the left here you see the existing buildings, and they're surrounded by car parking. One of the first things we did was to pull the parking away and actually start to create a campus, giving it back to the users rather than dedicating it to the car. So this is our building going here on the north-south axis, trying to create a large central area in the middle, along the idea of a student quadrangle in a college, trying to create that sense of campus. And then in the smaller spaces alongside, creating those semi-public spaces where students can use those for study spaces, enjoying the great weather that we enjoy in the Okanagan. So this is the building plan. When you first look at it, it's slightly in terms of, it's very long, elongated, very articulated plan. And I'll come on to some of those reasons. Part of it is driven, of course, by the site itself. But just starting at the bottom of the building is the entrance block. This is really seen as a sort of gateway to the site, not only to this building but to the other buildings as well. So we very intentionally relate to the other buildings. What we don't want to do is sort of alienate the other buildings and make them redundant before their time, because that's self-defeating, because you're wasting a good resource. Within that entrance block, you have the atrium. So you have a lot of highly active student spaces, study spaces, reception, the cafeteria, a very active space, empty day. Alongside that is the demonstration workshop, which is really seen as the primary teaching space for the building, where they'll have the guest speakers and all the big publicity items. I'm just going to grab my water. Then running down the The spine of the building is this main corridor, and you'll see everything's exposed. Nothing's hidden. It's all about teaching the students. Everything's visible. So there's student study spaces alongside. On the east side of the building, we have 6 workshops for the different trades, with workshop yards outside. And on the west side of the building, on the quieter west side, facing the other buildings on the campus, are the classrooms. And also the offices. Now they look very similar, and this is one of the first changes that we came across during the SHREP process. We had a requirement for over 30 cellular offices for faculty. Now, if every office then has to have an opening window, that would stretch our building much further and be very difficult to actually control. So going through that process with the college and the faculty, we said, well, let's group faculty into groups of 6 people within one space. They share that space, it's a lot easier to control, but the finished space is actually the same size as a classroom. And that's quite important because the college recognised that during the life of their buildings, they have a huge churn rate, and they're doing a lot of refurbishment work. If you don't address this, then during the life of the building, you get a lot of wastage of building materials. If by having the faculty in the same space as a classroom, they can do the churn without physically changing the shape of the building. But this was one of the biggest challenges for staff. It wasn't the living building challenge, it was the challenge of sharing the workspace. To the north, we have the gymnasium, and alongside that is the Accelerate Okanagan, which is an incubator organisation for startup sustainable companies that would work alongside the students. Below the Accelerate Okanagan is the Kinetic Suite. So the whole of the north end actually functions as an independent section, and it has a separate entrance. It cannot actually operate separately from the rest of the college, so it can be open during the weekends for community use. So that's a very quick overview of the building, just to locate you. I'm going to go through the different petals. I'm not going to pick off everyone, just got time, just pick out some salient points. So looking at the site, I'd say it's in the Okanagan, so we have a very dry climate, less than an inch of rain a year. So that stormwater management that we were talking about earlier is not a big issue here. We have over 2,000 hours of sunshine, which is why everyone goes there for holidays. You'll also see the site is actually right in line with Pattison runway. The site is right about there. And if you look at the actual site here, we actually have a radio mast, which is the early warning beacon for the airport. So that actually controls the height of the building. We also have very poor ground conditions because we were between the two lakes, so we have layers of silt and sand. And that was a factor in terms of the design, because we didn't have time to preload the site. Also on the adjacent site around that radio mast is this little guy, the Lytis subulati, which is a red-listed provincial butterfly, which I'll come back to shortly. So I'm going to jump on water. The living building challenge, I think each building is very much a response to its own site. There's no one solution fits all. And we had the great advantage that Pattison had just built a state-of-the-art water treatment facility. Now this is quite significant because we knew that treating our own water on site was very costly, and we had a very, very tight budget. We thought that might be a petal that we'd have to set aside. But their water facility was state-of-the-art, it was completely chemical-free, and it's literally just across the street. So it was the scale jumping that was mentioned earlier, that we approached Living Building Institute, said, can we do this scale jumping? So the way this works is we have City of Pattison hospital water coming in. This is, again, as touched on, that was mandated for kitchen sinks, bathroom sinks, anywhere where you might be drinking the water, that was mandated, it had to be potable water. So grey water coming out of that joins any black water from the WCs and urinals. That's actually exported across the street to the city facilities. We then import back exactly the same volume of water back on site as treated grey water, and as treated to a standard that can be put into the river system. So that's then used for flushing our toilets and irrigation. So that was a big plus for us, because it obviously saved us a huge amount of money. On the roofs, we have large areas of PV on the roof, with some smaller areas of green roofs. In the Okanagan, the green roof is a little bit of a different dynamic. It has a huge advantage in terms of thermal mass and cooling the building. But we have such low rainfall, you end up irrigating green roofs typically, quite heavily, in order to keep them dry. So what we've done in order to maximize and minimize the amount of irrigation is the water that's collected on the large areas underneath the PV, that is actually channeled and distributed onto the green roofs at a slightly lower level. So we get a factor of something like 1 to 4. So when it rains, we get 4 times the amount of water actually distributed onto those green roofs. And those green roofs are typically quite a shallow soil, and because they're up on the roof all the sun, they're quite prone to drying out as any green roof. But shallow, dry soils is also exactly the same condition as you get on the hillsides around the Okanagan. So we then went to native planting on those green roofs to try and experiment to see what plants we could use growing on there would actually work, rather than the standard sedums that you might see around Vancouver. Which comes back to, hopefully, we'll attract this little butterfly like this Sabalati onto our roofs, but let's see. I'm looking forward to that photo. Okay, so moving on to the indoor quality, which is all about giving control back to the individuals in terms of their work environment, the living environment. It comes back to this articulated plan. So, this articulated plan is derived because we're on a north-south axis, which is not ideal. We have these rings on the west side to try and maximize the north and south light coming into those teaching spaces and just improve the daylight penetration into the building. So the north and south light in these classrooms is a lot easier to control. And then we have very tiny little punch lights on the west side, which is a lot harder to control, but we just have those wherever the building plan is deep. You want some extra light penetration to the windows. It's just one of the lighting models for the spaces. So we have typical gris-soleil on the windows. You're all familiar with them, so shading the windows in the summer to avoid the worst summer heat. But then the low angle winter sun is coming into those spaces, so we get the sunlight, and we also get the benefit of the heat in the winter. You'll see that we've dropped the gris-soleil down, so we have a clear story above. And then inside we have this opaque glass light shop. So that the concept is that the light coming through the clear story is hitting that light shop and bouncing up, reflecting off the ceiling, and then reflecting further back into the space. So just getting much greater light penetration. We also have very tall windows, again, to maximize that light penetration. On the atrium in the south, we have the same principle. We've got a large area of glazing in the south. Again, with a large overhang and gris-soleil. And the intent there is to use that space, which is more active space, so you can allow a bit more sun to come in, to use that as a heat collector, and that heat is then distributed through the air system through the building. This is just some of the lighting models you'll see here. So this is early morning in winter, high clear story windows up underneath the roof hang, so we get light into those workshops to get that early morning preheat. You see the south here is in full sun in the winter, and in the summer it's completely in shade. At the north end, where we mentioned the Accelerate Okanagan offices and the Human Kinetic Suite, which is a much deeper kind of space, we have this experimental system which is coming out of UBC, Professor Lorne Whitehead, which is actually a sun trapping system. The way it works is you have a series of collectors on the outside of the building, which are mounted on the side, which have an array of mirrors, small 6-inch mirrors, which actively trap the sun during the day. So it's not collecting skylight, it's collecting direct sunlight. That is then redirecting that sunlight through a series of lenses and into a series of pipes and condensing it. Don't try and understand the image, it's hard to get your mind around what you're looking at. basically it's condensing the sunlight into a pipe, much like an air conditioning pipe, and then sending that through the window and ducting it through the building. So you're using sunlight which just pops out like a normal light within the building. It's one of 6 buildings across Canada which is where this system is being trialled. And that's very much what the building is about. It is about trying new systems. So the ventilation system, we open windows, indicated by a green light, red light system within each room. It tells you when it's appropriate outside, you can manually open the window. There's no automatic system. It's all down to the occupants having choice. They can open the windows if they wish. You have fresh air coming in, lower cost space, heat meeting warm bodies, rising in a column around those warm bodies, and out through a vent through the corridor, and then out through these chimneys. And you'll see these chimneys along the length of the building. So these are using that stack effect, going up to high level, mixing with the ventilation from the workshops, and out through the louvers at the top. And the louvers are adjustable to make use of the best prevailing wind. We have a very good north-south prevailing wind. And on the south side of these, we've added glazed windows. Those glazed windows are there to use the solar gain to heat the air coming in that column, to warm that up and actually boost that stack effect. And this graph is actually showing the comparison. The red is without the windows, and the blue is modelled with the windows. So it'll be interesting to see if they perform as modelled. And then in the winter or in the summer when it's too hot, the red light comes on and people know that they don't open the windows. We go for a displacement ventilation system. That's great because you're separating out the heating system from the ventilation, so you can get much greater efficiencies. Cold air is coming in, meeting warm bodies, and again rising. We have a high floor to ceiling, so we can allow that air to stratify and build up quite a heat up a high level above people's head, and it's not a problem. That's venting out through the corridors and through a high efficiency heat recovery system. We use radiant heating in the floor, which everyone's familiar with, I'm sure, using a geothermal system. The same system is used for cooling, so we use the natural temperature of the groundwater for cooling the building. There's no artificial cooling within the building, it's purely that temperature of the groundwater. That gives us lots of advantages in terms of natural ventilation. Typically natural ventilation would work for maybe 6 meters into the building before the air starts to warm up and start to rise above people's heads. So in a naturally ventilated building, if you're further than that, it can start being quite stuffy. But because we're cooling the slab actually keeps the air cooler for much longer. So this is a modelling of a typical workshop. So we're pulling air coming in the windows, and it's going across the full width of the workshop, which is 15 meters, out before it starts venting up the chimney. So we come to the gym, and this is, to me, this is one of the good examples of a holistic solutions of it, and that IEP process I was talking about. The gym, we had a problem in that you have a timber floor, and that effectively insulates any radiant heating under the slab. Also, if you start putting cooling in there, you have the potential of condensation in your timber floor, and you might get rot and mold. Plus, I mentioned we had the problems of poor ground conditions, so we couldn't have too much weight. And we hit upon this solution of a composite panel. This is a prototype being built. This is proposed by the structural engineer, Jerry. Whereby we have a very thin concrete slab, and we go for a constant action between the concrete and the glue lamp beam supporting it. This is the prototype with the beams on the back. The finished panel actually has the glue lamp beams on the side. Because it's constant action, the glue lamps stiffen the concrete, and the concrete stiffens the glue lamp, so both can be reduced. So these panels, they go up to 10 meters in height, but 3.6 meters wide, but the concrete is only 3 inches thick, 75 millimeters thick. So that's probably more than half of what you would expect with a precast concrete panel, tilt-up panel. Within that concrete, we have the radiant heating system embedded within the wall. And so we have radiant walls within the gym. And this is the finished product. So the radiant heating is in there, the duct is providing the displacement ventilation, which is ducted down to the back of the panel, coming out of the fence from the bottom. So by doing that, we significantly reduce the embodied energy within those concrete walls. And we're also reducing mass on the poor ground conditions, so we can reduce the number of piles under the building. I'll come back to that at the end if we have time. There's a bit of a tail on that one. So materials, going on to the materials one. The red list has been touched on many times. Marsh touched on it very well. I'm not going to go through all of those. It's an absolute nightmare for anyone doing a living building challenge. It's a huge amount of time in terms of researching those products. I'm going to touch on appropriate materials. We've seen this diagram already with the different radii coming out of Penticton. The same diagram superimposed on population. I'm thinking population as in terms of centres for materials. And you see there's a problem. You know, from Penticton, 1/3 is the Great White North, nothing. You know, almost half of it is the Pacific Ocean. So we have, very little in terms of population centres where we're getting materials from. This is for the very lightest materials, is barely touching the American Midwest. FSC was another one that was again mentioned earlier. LBC mandates that all wood on the project has to be FSC. But living in BC, I'm sure you're all aware of the issues of pine needle kill and just how huge it is, particularly living in the interior in the Okanagan. There's a lot of small communities which are seriously affected by the reduction in wood stock. So not only is it an environmental issue, it's also a social issue and an economic issue for a lot of those communities. So I think, again, it was Marsha who mentioned that we went back to the Living Building Institute and said that, the college really wants to address this. We can't go to FSC. There's not a lot of FSC produced in BC and buy wood from elsewhere when there's this huge environmental, social and economic issue right on the doorstep. So we came up with a series of parameters of using pine beetle kill instead of FSC. And that was when the decision was made to go to a timber frame construction building. And that really ties in well because timber frame would be limited to 2 stories for an assembly building. And of course we're limited by height anyway because of the tower on the side. Going to embodied, down to timber, you can see that the embodied carbon within that is significantly less of what it would be for steel and concrete. And I would maintain, because we're actually right to the heart of the timber industry and there's not that long travel distances for shipping timber to the site, I think the actual figures for timber on the site are probably less than that. So energy, we're going to go through that into the 3-stage process. How do you target net zero energy? Through conserve, capture and create. So conserve is all the things that we've heard about already. We're all very familiar with going through a high performance building envelope, triple glazing, etc. Just conserving the energy that's within it. The next part is the bugbear for anyone doing LBC is the uncontrolled plug loads. That's out of your control. That's what happens once you hand the building over. So we have little dashboards within each classroom so each classroom can see their energy use and workshops, their energy use in real time, how that's comparing to the intended target energy use for that time of day and that time of year. So hopefully by encouraging awareness and also maybe a sense of competition between classrooms, we may encourage them to reduce their energy load. And certainly judging by their sort of feedback and the encouragement to meet those targets, I think they stand a good chance. So the next stage is capture, going through. So it's all the things we've already talked about: passive solar dome, natural ventilation, and the ground source heating and cooling. And then finally the light pipe technologies, using any free energy that we possibly can to bring it into the building. So then by those 2 measures, this is a standard reference building, this is our proposed building. You can see there's a huge difference, and that's that's only by addressing those two first will you stand any chance at all of achieving net zero energy. Interestingly, you see that there, the purple, which becomes a much bigger proportion of the overall pie, is that uncontrolled plug loads that we're talking about. So then we get into the create, the renewable energy that you have to do on the site. So solar hot water and photovoltaics. Solar hot water, we have two systems of solar hot water, again for that experimental nature that the students can do a comparison between the two. It's not actually a huge component on the college because it's not actually a good fit for the college, although it's a very efficient technology. The student demand is typically mostly during the winter months. So if we actually size the system to those winter months, we would have a system that was completely oversized during the summer months. You'd have all this energy that you'd be generating. We would get into the silly scenario where we'd have to have a chiller to get rid of that heat. So we have a limited amount of solar hot water, and instead we've invested our money into the solar PV. So that's the solar PV, one of the largest PV arrays in Western Canada. It's generating in the order of, or planned to generate in the order of about 300 kilowatt hours per annum. So moving on to beauty and inspiration. As I touched on before, I think the Living Building Challenge is all about creating a building that really does respond to its actual site. And there's lots of things that's specific to this building that wouldn't work for the next one. But what I wanted to dwell on was the First Nations. We had a conversation with Jeanette Armstrong from the local First Nations right at the start of the building. And there's a lot of similarities between going back to old traditional vernacular architecture. The physical similarities, their winter hut or winter quincy would be located on a south slope that got the first winter sun, as well as the first sun in the spring and after a winter, to try and warm it up. It would use natural ventilation. It's recessed partly into the ground to use the mass of the ground. But the conversation went on beyond that, and she talked about the four columns at the centre of their quincy and how they treat that as a fulcrum, as a balance between change and tradition, we've got action and consequences. Just if anything becomes out of balance, they talk about bringing that balance back to the centre of the quincy. And I think the analogy you don't have to stretch it too far to see that the Living Building, that the Centre of Excellence really tries to do the same by getting a balance between traditional passive technologies and new modern technologies of PV and that, and trying to readdress that what was out of balance through the decades of dependency on fossil fuels. So the other part of that is education, and I come back to the name. We're not at the end of the presentation yet, but I come back to the name of the project, and the whole focus for the building is to be teaching students. So that's very much a focus. I hope the building addresses that side of the Living Building Challenge. We talked about the different features within the building, but I think a lot of the teaching is going to happen on the roof. We talked about the PV and all the different systems. On the roof, we have this little pop-up where we have a glazed classroom where students can go up and look outside or visit it. And then this area outside, which we refer to as a Petri dish, which is intended for those future systems that we don't know yet what they're going to be for experimentation. So cost, just briefly, 27.6 million, 7,000 square meters. So that's working out, for those in Imperial, that's roughly $375 per square foot. That's directly comparable to other buildings that the college had just completed, that were targeting LEED Gold, LEED Platinum. There was no additional funding for Joint for Living Building Challenge. It's a standard ministry funding. I think various factors in achieving that. One was we were building in a depressed market. That was obviously a big factor. But also that those holistic solutions whereby one element of the building is targeting several different components, as well as stripping out a lot of traditional finishes within the buildings. If you walk around, it is quite bare bones in places. There's no air conditioning system, so there's another big cost to go. So to conclude, and just wanted to go back to achieving living building challenge, or targeting living building challenge, the challenges of that, the challenges of the fast building process. And we use the analogy of a stool for the design team, the three components that really sort of brought it about. So the first is the college, and that grassroots sustainability initiatives at all sorts of levels, within the students, within the faculty, and the exec. It was a great client to work for. They were quite willing to take those risks, going through, analysing the risks, and we would be open about them. But they saw the bigger benefits to them of a building that's leading edge than purely the nuts and bolts. The next one is the design team. Absolutely great experience to work in the design team. It was chaotic at times, it was frantic, lots of bouncing of ideas around. I mentioned the gym panels as a great example of those solutions that fit all. And then finally PCL, who are the construction managers. Again, very proactive, a key part in terms of making it happen. Again, I smiled when Marsha talked about the analogy of the flower. PCL did, prior to tendering, they actually had a lot of presentations to the local construction industry, so people knew what they would be tendering, going through the Living Building Challenge, which nobody had ever heard of. And we were parties to those presentations, and I was chatting with one of their project managers and trying to encourage them, saying, well, yeah, you can do the living building bit, you can present that. And he's saying, yeah, but I'm going to skip that flowery stuff. So that's teamwork, and I think it was key to have those three major parties really wedded to the system. But it was the vice principal of education from the college who said, yeah, well, we use this in our presentations, but it's not right, because it implies all decisions go up to the top, and the sharing is at the top. And the actual model that happened was more like this, where the links are at all levels, and that communication is at all levels. Plus it's made out of recycled cardboard, so even better. So this is the website if you want to see more. As architects and designers, we get to do a little bit more. We get to design green buildings, we get to design LEED buildings. Occasionally we get to design living building challenge buildings, and that's exciting. But what was driving this team, more than the fact that the living building challenge and the building itself, was the fact that the building is going to be teaching sustainable trades. So the impact of the building is much greater than just this building. It's actually influencing the whole of construction industry in the Okanagan and hopefully across BC. So with that.